Okay, everyone. So when you're working with a Pythagorean theorem and still getting used to it, it's a good idea to have it written somewhere on your page where you can see it easily so that you can just plug in the numbers as you go along. So we're going to do a few examples here. Starting with problem 1, I'm going to do the second triangle. So the first things that we have to think about is that we have to identify the hypotenuse. And if you remember, the hypotenuse is the longest line of the triangle, and it always lives opposite to the right angle. So for example, here we have the right angle, and there's the hypotenuse. If you look everywhere else, there's the hypotenuse. There it is. And even sometimes it's if the triangle is upside down or facing a weird way, or some of the side lengths are really similar, you can always just check which side is opposite the right angle, and that makes it really easy to see which one is the hypotenuse. And when we plug the numbers into our Pythagorean theorem, typically the hypotenuse is represented by c. So a squared plus b squared are on one side of the equal sign, and c squared is on the other side. So c squared will be the length of the hypotenuse squared. Okay, so let's begin here with number 2. And here we have a hypotenuse that is length 2. We have one side that's length 1, and we have one unknown side that is connected to our right angle. So I'm just going to plug those numbers in. I'm gonna call this side down here a, so I'm going to put 1 squared here, and I'll call the unknown side, it's called x, so I'll put x squared equals 2 squared. So just as a side note, when you're trying to figure out which one to choose as your A and which one to choose as your B, it doesn't really matter. Because they're being added together, the order is not important, so you can just choose whichever one works for you. It's the C that matters, so you have to make sure that the hypotenuse is on the other side of the two, of the A squared and the B squared that are being added together. Okay, so where do we go from here? A little bit of algebra. 1 squared is equal to 1 plus x squared. I'll leave that as it is. And 2 squared is equal to 4. And how do we find what x squared is? So I'm going to subtract -1 from both sides. Or rather, sorry, I'm going to subtract 1 from both sides so that I end up with x squared is equal to 3. So if x squared is equal to 3, what is x? I will have to put a square root on both sides. On the left side, the square will cancel out with a square root, and I'm left with x equals square root of 3. Can I express this as a decimal? Well, not exactly. As we learned, I think 1 or 2 classes ago, only the square roots of perfect squares can be represented by integers or fractions. Most other numbers can only be defined exactly using the square root symbol. So if you plug in x equals, or if you plug in square root of 3 in your calculator, you'll get something like 1.73205 and so forth. So that's just an approximation, but it's never going to be exact. So the only way we can give the exact answer is in square root form. So there it is. Let's try number 4. Okay, so in number 4, let's take a look here. Our hypotenuse is x, and we have a side length here of square root of 6 and another side length of square root of 10. Well, now you might be wondering, how am I going to deal with that? Well, let's just use it exactly the same way that we used the other numbers. Let's just plug it straight into our formula. So for a squared, I'm going to make my a side the square root of 10 side. So I will write square root of 10 squared plus b squared will be square root of 6, square root of 6 squared, and that is going to equal my x side squared. So that's my c. This is my hypotenuse. And now we can work this out. Well, you know that a square and a square root cancel out, so this just becomes 10. And same thing here. So 10 plus 6 is equal to x squared. 10 plus 6 is 16, and that's equal to x squared. And now in order to find the value of x, I put a square root on both sides. And we are very lucky that 16 is a perfect square, so we'll be able to get rid of our square root and write x equals 4. And so 4 is that missing side length.